the channel. This is Mike from UnknownTech.io, and in this next chapter of Getting Started with Kubernetes series, we're going to be on episode 10. I hope you read the blog post, and what we're going to do is we're actually going to walk through some of the Kubernetes Manifests or YAML specifications connecting to and using API resources within Kubernetes. We're going to focus on the basics, pods, deployments, and replica sets to actually deploy your applications. And we'll focus on that just today. There's many others which we'll talk about later. But before we do that, we have to prepare your workstation because I like to use a few tools, and maybe you guys like to use a few tools as well. I'm on a Windows 11 machine. You can see this box here that I'm on. And you can see I have PowerShell command line up. And what we're going to do first is we're going to talk about two things. WSL, which is Windows Subsystem for Linux, and we're going to talk about vscode, which is a tool that I use to manage all of my scripts, coding, notes, etc. And then later we'll talk about how that process gets integrated with Git, and we'll talk about how CI/CD works, etc. But we're not even quite there yet. So let's first prepare a workstation. So this will only be on Windows 11. I have Windows 11 Pro. Some of you probably use Mac or a Linux workstation. You can use VS Code on either one of those. WSL is only for Windows because what we're doing here is we're actually installing a quote-unquote, for lack of a better term, a virtual instance of Linux on Windows. Okay, so what it does is it uses the Hyper-V extensions underneath the covers to actually install the Linux subsystem. So what we're going to do is I'm just going to show you quickly how to I already have it installed, so I'm going to show you quickly what you can do to install WSL. So what we're going to do first is we're going to do a WSL --list --online, and this gives you all of the Linux distros that are available to you to install under WSL. For me, I use Ubuntu. Okay, so I leverage Ubuntu, and you can see here after you install it, if you just drop down, you can see here now I have a connection to my Ubuntu Linux machine right on Windows, which we'll get to in a few minutes. And in order to install, what you do is you basically do a WSL install, right? And you can do a -D, and you can see here you can choose the distribution here, and you can hit enter, and it'll walk through the install. And I can't remember or recall, I think you have to reboot in order for it to fully be deployed. When you reboot though, and let's assume you install Ubuntu, right? Again, you'll have access to the Ubuntu station. You can see here I'm actually running Ubuntu right within Windows. So again, there's not a lot of magic behind this other than the fact that it's using Hyper-V under the covers. It's different than actually launching the Hyper-V utility and going through that process and then creating a virtual machine. It actually does this for you. It automatically bridges the networking right on your network interface within your Windows 11 machine. So the Ubuntu virtual machine basically is bridged using your Windows 11 NIC here. So now that we have that installed, the next thing we want to do here is we want to install VS Code. So I have VS Code installed already, and I love this tool. It's one of the best tools that Microsoft ever made, I think. But essentially what we're doing here is we have a platform we can actually build our scripts, use code. I can integrate into Git. I have several other extensions that I use, which we'll talk about later. But essentially what I do is I use, obviously, GitHub Copilot, which is one of my favorite extensions, which basically allows you to ask questions, right, of Copilot, to use AI, right, to get information back on specific code snippets or formatting or anything really, which is really, really nice. And of course I have the WSL extension. So what does this do? It allows me to actually integrate, right, with the WSL machine. So you can see here that I have a terminal stood up, right, down here below, and this terminal is my Linux machine. right, that we just did for WSL. It's my Ubuntu machine, right? So this is really nice, the fact that I can, you know, stay within Windows 11, leverage Windows 11 like I typically do for work, for Outlook and all PowerPoint and all the stuff that I use for Windows, right? As well as, you know, even outside of work for gaming or anything else, because Windows is the best gaming platform right now, right? I mean, Linux is coming, but it's not quite there yet. So again, having a workstation that can do everything is very, very powerful, instead of having me dual boot or have a separate Linux virtual machine to do things. Now, I do have those things. We'll talk about that later, but this allows me to do a lot of things through one system, which I really like. One of the things I want to point out too is, why are we talking about this, right? So before, what we were doing, accessing our Kubernetes cluster, right? We were going right to SSHing right to the control plane node, okay? Which is not what we want to do, right? We're not going to give, you know, others access to SSH into the Kubernetes nodes. I mean, as a Kubernetes operator, right, or a platform engineer, more than likely you would have access for that, right? But the reality is that's not how folks are going to be interacting with the Kubernetes cluster. So when you're giving developers access or rights, etc., you're going to create accounts, you're going to create a role. We'll talk about role creation, role mapping and binding, service accounts, etc., a little bit later in the series. But the reality is the consumer or user that needs to deploy on the Kubernetes cluster will be on their workstation. So the question is, how do they access the Kubernetes from their workstation? Well, we've been using kubectl, right, all along to interact with our cluster. And we're going to be using the same utility remotely on our machine. The question is, how do I access this cluster remotely? Okay? And so, generally speaking, when you build a Kubernetes cluster, right, what will happen is a file will be created, right? And it will be what we call the Kubernetes config. You'll hear people talk about kubeconfig file, right? That config file is generally under etc, /Kubernetes, and it's called the admin.conf file. All right. So now that you know that where this is, what we need to do is we need to copy this file back to our desktop. And so I use a tool called WinSCP, which allows me to connect, right? We obviously know the security certificate, right? The key, the private key file that we used when we created our cluster for this machine. And we're going to, just like PuTTY, we're going to use WinSCP to connect, which I've already done here, to this SCP to this machine. We're going to point to our certificate, right, to allow access. And we're going to browse in this directory, what you see here, to the right-hand pane, to admin.conf, and we're going to copy this file over. So I've copied this file over already, and I renamed it config1. Don't worry about config2 right now. Just worry about config1. All right. So config1 is now in my desktop. So now what I'm going to do is I'm going to go into my Ubuntu WSL machine, and I'm going to install kubectl, which I've already done. Okay, so if I go kubectl, right, you can see here that kubectl is there. Let me just make this bigger so you can see it. And I can do a kubectl version, right? Oh, kubectl version. And I'm using 130.0, right? Which is obviously older than the server side, or newer, excuse me, than the server side, which is okay. Generally speaking, you don't want to be older than the server side. You want to be the same or newer from a kubectl perspective. So now that I have kubectl installed on my Ubuntu workstation, how do I access the cluster? So what we've done is we've copied that file right over onto our desktop. So it's a little bit different. So if I go to change directory and I go to mount C users Mike desktop, right? Now I'm in that directory. So I do an ls, right? Now I have all of the, now I'm looking at the desktop, right? So it's a little different than the directory structure, right? When looking at in Windows, right, you would just do a C. It wouldn't be the forward slashes. It would be, backslashes, etc. to go into the Windows directory structure. But I'm in a Linux Ubuntu machine. So how does that translate back to browsing the actual Windows environment, right? Because my files are on Windows, right? Even though I'm in a Linux machine, virtual machine, I need to copy this config file over here. You can see config1 and bring it into the fray, right? To leverage access into the cluster. So now that you see that, and now you know where that config file is, what we have to do is we have to copy that file into the directory. And I'm going to show you what directory here. So let's do a cd. We'll go home. Let's do a clear. And we'll do, after we install kubectl, a directory called .cube will be created. Okay? So now that .cube is created, we can go here, and that's there. We're going to copy that config file over to this directory. So what you do is a copy, and what you'll do is a mount C users mic. That's my login, right? You would have your own login under users, right? Whatever your login name is, and go to desktop, right? And then go to the config file, right? And we're going to copy that right into the directory that we're in, which is .cube. So you do a /, which is the directory we're in. So I've already copied this file. I don't need to copy it again. So if I do an ls, you can see here I have config1. Again, ignore config2 for now. I have config1 there, and now I have the Kubernetes config file for our lab cluster on my local Ubuntu machine. Now, we're not ready yet. We can't use kubectl yet. What we have to do is we have to set the environment variable to point to that config file. Now, I actually have a couple clusters. You can see here config1, which is our lab cluster, the single master, single worker node lab that we've been using throughout the series so far. But I also have an OpenShift cluster, right, that is deployed on, also deployed on Nutanix. That's something we're going to talk about later. I was preparing that for upcoming sessions. And so now I have two clusters I need to interact with. Now, I'm not going to get into context, which is basically how you change clusters, right? But what I'm going to tell you is I already have this set up, so it's going to be a little bit different. In your case, if you're just interacting with one cluster, all you have to do is change the variable through export kubeconfig, right, equals, and in my case, the home directory, .cube, right, config1. And in your case, if you renamed it config1, whatever you renamed the admin.conf file, which is the kube config file for our lab cluster, right, that's what you're pointing to. That's what you're setting the environment variable for kubeconfig to point to. So when you do a kubectl, it automatically uses that kubeconfig file, okay? Now, because I have multiple kubeconfig files, what I'm going to do is I'm going to separate the two with a colon and put in the path of the other file as well, okay? Now, when I do that, what I'm saying is I have multiple kubeconfig files, and that allows me to choose, right, between clusters as I move between them for my management tasks using kubectl. And how we do that is we do kubectl config get context to list out the Kubernetes clusters, okay? Because now kubectl realizes after you did the export, set the environment variables, and you point to the multiple kubeconfig files, that I have multiple clusters. And because I can see the context of what I'm on, the star, right? You see where it says current context under the left-hand side here? Where the star is the cluster that I'm interacting with. This happens to be the lab cluster that we have been interacting with on the series. Above here, you can see I have another cluster named admin, kind of a stupid name. I'd have to rename that. And what happens is if I choose this context, I'm now able to interact with my OpenShift Kubernetes cluster, okay? Now, we'll get into more detail on context. Very important that you be able to switch between the two or various clusters. On the CKA exam, if you plan to take that, you'll be doing this all the time, all right? Because each question will say, okay, on this Kubernetes cluster, do XYZ task. And so you're going to need to change the context of the cluster that you need to interact with for kubectl. Okay? So I know that's a long-winded explanation on how to get your workstation set up, but now if I go back to here, home directory clear, and I do a kubectl, and by the way, I always set my alias, right, because I hate typing down kubectl all the time. So make sure you set your alias, and this is another hint that you'd want to use for the CK exam to make it faster, right, to just type in K versus kubectl all the time. You can do alias K equals kubectl, right, and I've already set that up. So if I go K get nodes, nope, if I can spell right, nodes, right, my alias is already working, right, I've already set the alias up. So just understand for the remainder of this video, when I hit K, it's actually kubectl. Okay, so when I type in K. Now that your system is set up, you're actually interacting. You can see here, get nodes, O wide. Oh, I can't even spell today. Hang on 1 second here. Okay. Now you're interacting with the cluster from your desktop, not on the master like we've been. Okay, and now you're on your desktop and you're remotely connecting to the API, okay, the API URL for the Kubernetes cluster. And you can see here it's the same cluster that we've been working with. You can see the updated version that we did in our last series when we did the maintenance operations for upgrades. We're on version 1.29.4, right? I did an OY to give you more information, the OS images, you know, Ubuntu 22 kernel version, in the container runtime version, right? And we can see here that the control plane is there and the K8s worker node is ready. So we are ready to go on and move on to Kubernetes Manifests. So let's go back, we'll clear the screen here. We're gonna drop this down. I made this bigger so you guys can see it, so I'm not gonna have a lot of room. But essentially, what I'd like to do is go to a folder. So what I do is I have a folder structure within my desktop under a folder called Home Lab. Okay, so if we go under my desktop and I go to my C drive, I have a folder called Home Lab. In the Home Lab, I have several folders here. But what we're focused on is K8s Manifests. Okay, we're focused on Kubernetes declarative management, right? And we do that through manifests. Now, if you skip right to the video, I would ask that you go back to the blog post, okay, and read through the blog post, because it's going to talk about the Kubernetes API. It's going to talk about YAML specification, which is what we use for our manifests, right, to create our manifests for our declarative management. And then what we're going to do is we're going to walk through those three examples of a pod manifest, a deployment manifest, and a replica set manifest. And we're going to bring it all together, because when you do, and this is one thing I talk to a lot of people about, it's good to separate manifests out, okay? That's okay to separate those out. The problem with doing that is now you have all these different manifests for different things. So when I deploy an application, I'm not just deploying the application from a pod perspective. So let's take a step back for a minute. When I did my testing, matter of fact, let's just go back here. Let's make this bigger again, and we'll do a K get pods -a. As you remember, I created this Nginx pod post the upgrade to make sure everything was working after the upgrades that we did for Kubernetes. Okay, you can see it's here, it's running, it's healthy, right? It's been up for 4 days, 21 hours, which is the last time I did the video. And now it's healthy and working, okay? That was just basically doing an imperative command. You saw me do an imperative command, which is basically the kubectl run command, which is, I'm doing a command, right, to say, okay, just stand up a pod. That's not the declarative way of doing things. Now, here's where it gets confusing. Kubernetes is really about declarative operations. right? It's creating a config, right? And basically applying that config to Kubernetes to get to a desired state, okay? And that's really what you're trying to do. You're trying to always get to a desired outcome. And with manifest files, you can do that, right? You can create a pod, right, through a manifest, which we'll talk about in a minute, but you can also do it imperatively. Now, the reason I say it gets confusing is because when you do the CKA exam, in order to save on time, you're going to want to do a lot of the things imperatively. So it's going to be a combination of running commands to do things, which is the imperative way, like using kubectl run as an example, but also building YAML specifications, which is really what this session is focused on, the declarative way of using Kubernetes, which is the right way of doing things, okay? Imperative stuff is good for testing, things like that. It's not good for production. It's not good for really how you manage your environments, because you want to be able to basically build your manifests, and you want those manifests to be uploaded into Git, and you want collaboration on those manifests, meaning you want to make sure the manifest looks okay. You want other people to view it, to approve it, to have second eyes on it. You want to make sure that everything looks good, right, before you apply it. Because when you apply it, you're actually running the application, right? Whether it's in a test environment or a UAT environment or even production, those things have to go through what's called a pipeline. And we're not there yet, right? We're very early on in the stages of Kubernetes, right? We're not even getting to the point of CI/CD. But the point is, and the goal is to make sure that you're actually coding it as a Kubernetes operator, right? Or someone who's building YAML, right, or Kubernetes Manifests. You're actually doing some coding here. You're becoming a programmer, basically. Now, when I first went down this path, right, this was very foreign to me. Now, it may not be foreign to a lot of people because you may have always been doing some sort of programming, whether it's PowerShell scripting, Terraform, things like that, right? When I got into this, right, I wasn't doing a lot of that because I'm not in an operational IT role. Okay, I'm in a, lack of a better term, I'm in a sales role, right? Sales engineering role. So I don't do a ton of that every day, like an operational IT role would be doing. And I haven't done that in years. I've done it in the past, but I haven't done it in a long time. So getting back into this, not just the Kubernetes side of it, but also the infrastructure as code side of it with Terraform, the config management side with Ansible and things like that, right? It's a lot to take in. And so I would basically just say practice is how you're going to get good at this. Constantly doing it all the time, repetitive, practicing, standing up lab environments like we're doing, testing things, right? And you're going to learn that way more than you're going to learn reading any book. Now, using books and things like that is fine for reference material or the Kubernetes IO page or the Terraform page or whatever, right? That's fine to leverage a reference, but nothing beats a lab and actually putting it into practice. So again, I would implore you to kind of take the route we're taking with learning Kubernetes, deploying your own lab. Now, you don't have to do this, right? You can go to Code Cloud as an example. You can use killer.sh, which basically is an environment for you to leverage to test your skills against before you take the exam for CKA. But there's nothing that beats standing up your own home lab environment, because now you're actually building it and now you're using it, right? Whereas those other environments, you're not really building anything, they're built for you, right? Okay. I know I went off on a tangent there. So let's do this. Let's delete this pod. So cube delete pod. Now remember, we talked about short names, right, in the blog post for this, right, for this this week's session. So kubectl delete po. So basically what this means is kubectl delete pod, right, nginx. Okay, so now if I go back in here and get pods, -a, nginx is gone. Now, I didn't specify a namespace. We talked about what namespaces are, right? in the previous sessions. So when I deploy that Nginx pod, I didn't specify namespace, so it automatically goes to the default namespace. Okay, and a pod is a namespaced API resource, and we talked about that as well. So let's go back to, let's clear this out, and let's go start with kubectl API resources. Okay, now I did this for a reason, because this is all, let me scroll up here. There's a ton of API resources, right? So this is basically what we're going to be interacting with, these resources. And it's important that you know this command, because you're going to want to understand when we build the YAML specifications, you need to understand what the name is and the API version is. Okay, so when you first start out with your YAML specification, those are the first things that you look at. So let's look at Nginx here. I already have an Nginx YAML specification, and when I scroll down here, this is actually a deployment. We're not going to do a deployment, we're going to do a pod first, but let's stop for a minute. Okay, so the first two fields in a YAML specification are always first the API version, okay, which is listed here, and the kind, which is the kind of resource under name. Okay, so let's go to deployments, and you can see here deployments. Here's a short name deploy, so when you do a kubectl command on a deployment, you can use deploy for the short name. And here is the API version, apps/v1. See how this is, see what I'm talking about here? Now you can see that you understand by doing the kubectl space API dash resources, I can now get the API version and the name for the Kubernetes code release that we're on. So we're on 1.29.4, that's what we upgraded to, right? Sometimes these API versions change. All right, sometimes these API versions are in beta and they're not in production. Okay, and sometimes those API versions change over to production. And so that's why it's important, if you get an error, an API error or something when you create your manifest. So say, for example, you're on an older version of Kubernetes and you did a deployment and it would say it was alpha, right? Or beta, API version. And you upgrade the Kubernetes cluster and now it's in production now. Now it's a different API version, say it's apps v1, like this one is, and you don't know that, and you put beta in here, or whatever the API version was previous to going to production, and it doesn't work, that's the reason why it doesn't work. So it's important to go back into and understand, if you ever have a question or doubt about the versioning and the name, right, of the resource you're using. So under Nginx, this is basically a subfolder under Kubernetes Manifests. I'm going to create another file, and we're going to call this Nginx pod.yaml. Okay, and you can see here now that I have a workspace, right, to go on. Now, if you have GitHub Copilot, and this is what I love, so if I hit Control-I, I can say, write me a Kubernetes manifest for an Nginx pod. Okay, so now I have this, and I'm going to make it bigger so I can copy it, and now I'm going to go back up here, and now I can just paste that in. Okay, now that's the beauty about GitHub Copilot. You can learn this way, right, if you get stuck, but again, it's important to go back to the blog post right above this video and read the YAML specification, right, and why it's formatted the way it's formatted. Okay, so here's a simple pod specification. So if we go back into terminal, discard this, and we get into the pod specification, let's go to pod. There's pods. It's v1, as you can see, so API version v1, and the kind is pod. Okay, and by the way, I made a mistake. It's not under name for the kind, it's under kind. Okay, so it's in the right hand corner. So again, API version first, kind is pod. And you cannot use short names within this manifest. You can only use short names in the kubectl command tool. okay? So I can't do a PO here and expect it to work. It doesn't work, okay? So let's go back here to the manifest file. Under metadata, you can do a couple things. There's a bunch of things you can do under metadata, but for basics, what we do is we do, the name, okay? So I'll just name this Nginx, and I can label this Nginx. So app::Nginx. So when we deploy it, the label will be app::Nginx. So why is labels important? We're going to talk more about that later. But basically what labels allow you to do is it allows you to use labels, right, to do specific things, right? So I can say if the label is app Nginx, only run on this worker node, right, as an example. And that's called affinity, pod affinity, right? Kind of similar to VMs, right, where you have VM affinity, where you can go in and say, okay, only allow this virtual machine to run on this virtualization host, right? Similar. So I can say, okay, let's use app::Nginx and say any pod that has this label app::Nginx only run on worker node 2 as an example. Okay, maybe there's some special hardware or resources or something on that node that I want to make sure that pod runs, and I apply affinity policy to that. Okay, so that's one example of where a label would come into play. So you have your API version for pod, which is v1, the kind is pod, your metadata, which I've named, right, the actual pod, and I've actually assigned a label, app::Nginx, and now we're going to assign the spec. So what is a spec? The spec is basically the app. Where am I getting the app from, right? How am I accessing it? How am I exposing it? And there's a ton more under spec, but from a very basic, let's just focus on the application. So it's going to be containers, right? The name is going to be Nginx, and the image is going to be this image in this version. So I can do a version here if I want. I can do :latest, which basically is the latest image. Now I want to talk about images. I want to stop here. It's very, very important to stop here and talk about, well, where am I getting the image from is the big question. Well, by default, you're getting it in the Docker registry, okay, which is a public registry, which you're thinking to yourself, well, that's not good. Why would I want to go to a public registry and consume an image from a public registry? Valid points, okay? In your work environment, you are not going to use Docker registry or Docker Hub, okay, to pull images. You're going to have your own on-prem registry or a registry that's in the cloud. So Azure has Azure Container Registry, so you can use that. OpenShift has a registry service you can run on-prem called Quay. There are registries like Harbor, etc. So there are different types of registries you can use, registry applications you can use in your on-premises location, okay, which is what I would recommend you do. You're not going to build your application, your custom application, and send it off to a public registry like Docker Hub. You're going to host your own registry, which basically is a location of where your images are stored, okay? And remember before I started this whole series, I stated that you must understand containers before you even think about Kubernetes. And so if you didn't go through that process, I would suggest that you stop right here and go back and do a learning module on containers. You can go online, get an understanding of that, how to build a container, using Docker, etc., and then uploading that image to a registry like Docker Hub as an example, and then being able to pull that image down and deploy it. And that's what we're doing. We're going to, in this case, Docker registry. This can be changed, like I said, to point to your internal registry or different registries that you have, or even an Azure registry, and pull those images down to deploy on your cluster, because that's what we're doing. Remember what an image is. A container image is a package of your application code and all its dependencies needed for it to run, okay? So in this case, in Nginx, I have all the Nginx application code and all of the dependencies required to run on my worker node in my Kubernetes cluster. Okay, let me go back to the image again. We're specifying 1.14.2. Okay, if I left this blank, it would pull the latest. So if I left just nginx, it would pull the latest. I can do nginx :default, or excuse me, latest, which is basically the latest as well. So I can specify latest as well. Or I can specify another version that I want to pull down. So ports, how do I expose my container? Okay, what port will I be using to expose the container? In this case, I'm exposing container port is port 80. Okay, so basically what I'm saying is on port 80, expose this image's application. Okay, so this is a simple pod manifest file. If we go back and we do an API resources, right, we can see the kinds and we can see the API versions associated with those kinds, and therefore your first two fields automatically you should understand by going back and looking at this, right? API version v1, kind pod, metadata. In metadata, we name the pod and we apply a label to it. Okay, now you don't have to apply a label if you don't want, but in most cases you're going to label your pods. Okay, because how you interact with pods and how you whether you want to assign policies or things like that, you're going to want to label your stuff. Okay, it's extremely important to label your applications. After you do that, we're going to define the spec. The spec is the actual application, right? The container, right? So we do containers, we do the name, and we specify the image, the version, right? And then we specified in this case how we're going to expose the container. We're going to expose it through ports, a container port using port 80. Okay? So now that that's done, I'm going to hit save. And by the way, you can also set up vscode to automatically save every so often, so you have to worry about when you're going in here and changing things to save things. Okay? So now that nginx pod.yaml is done, what we're going to do is we're going to go back into our terminal. Okay? And we have to now go to this folder, right, in order to get this pod, or we have to, when we do the apply command, we have to point to this folder. Now, you also don't have to interface with this using vscode. I mean, you can just use vi, right? It's just a YAML file, right? So if I do, let's clear this out. All right, let's make this bigger so you can see. I can, look at this, nginx pod, and here, and now I'm in here, and I'm able to actually, I can change this, right? What I like about VS Code is it gives me the proper formatting. Okay. Now you're not going to have access to VS Code on the CK exam. You're going to be using your editor, right? I use VI as my editor. I'm just used to it. I'm fast with it. Okay. And I like using it. Some people like to use other editors like Nano, etc. I use VI. Okay. This is how you're going to be interacting on the CK exam. You're not going to have VS Code. All right. I'm just showing you VS Code as a tool to use to get you used to the proper formatting. It'll help you there to understand what it looks like. Now, another area or place where you need to be looking for this, and you can use this on the exam, hint, hint, okay, is the Kubernetes.io page. We talk about this 100 times, right? This is your friend. You're going to be able to use this, okay, on the CKA exam. So if you go here and I type in pod, I can click on pods, okay? Oh, imagine that. Now I have a YAML file, right? That looks exactly like the one we just created. I imagine that's what Copilot did. It probably found this on the Kubernetes IO site and pulled this as the pod it created for us. And so you can see here an example pod specification. So if you have a problem with formatting or a specification for a specific resource that you're interacting with on the CK exam, you can go on here. So say it says create pod named test on this cluster, right, and expose port, whatever, okay? Now you know what cluster you need to go on to, so you'll change the context, which we talked about earlier, and then you'll be able to go on and say, okay, on my Linux workstation, I'm going to create this pod specification manually, right? So let's just do this and I'll show you what I'm talking about, because this may be a little bit confusing. I go back into VS Code, okay, and you can see here, I'm just gonna exit out of VI. Well, I can just do VI nginx2.yaml, right? And now I have a blank canvas. So now what I can do is I can now go in here. So let's assume that, you know, you're only on Linux machine, you don't have VS Code. So don't worry about that. The fact that I'm in VS Code, I'm in the Linux machine now, okay? I'm in the terminal. Don't worry about VS Code or anything like that. How am I going to create that file? Well, simple. If that's what it asks for, copy this over, okay? And now it's copied. Now you have it here, and now you can mess with it based on what it's asking you to do. Remember I said, oh, name it test. Okay, so let's insert. Okay. Right, you save it, and now you're ready to apply it, right? You're ready to actually deploy it. So again, I know I'm going all over the place because I'm using different tools, but for now, understanding that you can use VS Code on your workstation to help you, right, to start out, but also being able to leverage the Kubernetes IO site, right, to look at YAML specifications and copy those into your YAML file that you created, and being able to save that. Right, so let's save that. So let's right quit. Oh, sorry. Right quit. And now if I do vi nginx2.yaml, you can see it's already there. So you can see here in VS Code, it's popped up, nginx2, because I'm in that directory. Okay. Now you won't see this again, like I said, if you're just on the Linux machine by itself, SSH into it. But if you're in VS Code, you'll see that. So again, very simple to create manifests. And now we're going to apply the nginx specification. And we can watch this. So if we do kubectl get pod nginx -y, we can see here the pod is running. Okay, so let's go and do a K. Let's clear this. Let's make this bigger. And now we'll do a K describe pod nginx. And you can see here again, the pod went to default namespace since we didn't specify a namespace. And you can see here the containers that are running. It's nginx container. You get the container ID, the image version, where the image came from, right? The image ID came from Docker Hub. And before I even get into this real quick, let's actually visit that site. Let's go to Docker. hub.docker.com. Okay, so this is your public-facing image repository for Docker Hub. Again, I would not use this in production for your applications. You're not going to send your custom apps and upload your images, right, and push these images into Docker Hub for your registry. You're going to have an on-prem private registry, or if you're using the cloud, an Azure registry service like, a cloud registry service like Azure Container Registry or AWS Kubernetes Registry. All right, so let's go here. Do a search on nginx. We can click on nginx, right? And we pulled 1.14.2. And obviously that's a very old version. The current version I believe is 125.5. Or you can just use the latest, as you can see here. So if we go back and we hit clear and we do k delete pod nginx and then k get pod, you'll see that k get pod. There are no resources found in default namespaces, so that means the pod is deleted. But we can also change the YAML specification, right, within VS Studio Code, or we can do it by going to this file. So we're already in this directory. So let's use our editor. And to be honest, this is where you guys really should be doing this in your text editor. And the reason I say that is because you're not going to have Visual Studio Code for the CKA exam. If you decide to sit the exam, you won't have this tool, right? You'll have a text editor, and you'll be able to actually edit your YAML files right within the Linux machine that you're going to be connected to for the exam. So let's save this, and now we're going to use so we're going to right click that, and now we're going to do a kubectl apply -f nginx pod.yaml, and we'll do a kget pod nginx. It's running. We'll do a clear. I want to make this as easy as I can for you guys to see this. We're going to do a describe pod nginx, and you can see here again nginx is running, and the image is now the latest image, which is the most recent image that is being pulled from Docker Hub. Now again, I cannot stress this enough. You can pull images from Docker Hub for like testing, for home use, things like that. But if you're in an enterprise, you're not going to use public registries, okay? So again, I know I've said this a couple times now, and I want to make sure this is clear. You're going to implement your own on-prem registry. As we get into more of the managed offerings or the packaged offerings like OpenShift, we will deploy Quay registry on-prem, and we'll attach that to Nutanix object services to actually store in the images. Now, that's kind of the way you want to do it, because now I can use objects to protect that data and replicate that data to another object's service. Maybe it's an AWS, maybe it's another Nutanix object service and another site. It gives me the capability to replicate those images across sites, across on-prem or in the cloud, other availability zones or other regions. So we'll do that when we get to the OpenShift section. But for now, let's just assume, we're at the very basics. We're going to pull these images from Docker Hub, okay? So let's delete this pod again. Okay. Now, one thing you can do to validate that the pod is working, okay, is doing what's called a port forward. Okay, so what we're going to do is we're going to use kubectl to port forward a specific port to the container port that's specified here in our YAML. Okay, and what that does is it allows a redirection of the local host to actually use that port to actually connect to this container to validate that the pod is actually working. Okay, so what we're going to do is, let's just make sure that get pod nginx. You can see that nginx is running after our previous deployment, or previous apply, right? So now what we're going to do is, let's clear this, let's make this bigger. We're going to do a kubectl port forward nginx the pod. Now, if you had a namespace, you would use a namespace here. Then you would choose the pod, or you could choose the pod and then the namespace. Okay, by using a -n. All right, and we'll do more namespace stuff here in a minute. We'll actually add a namespace within the metadata here to denote a namespace. Okay, to make sure that it gets deployed to a proper namespace versus just a default namespace. But let's get back to this. We're going to port forward nginx, right, to 888 and pointing to the container port 80. Okay, so let's see what happens when I do this. Now you can see that I'm forwarding from my local host to 888 and forwarding to port 80 to this container. All right, it's doing a redirection to that container. So how do I now validate that? Well, here's the good news. Since I'm on a Windows machine and I'm using WSL on Windows and I'm using a bridged connection, I can just open a browser, okay, and I can type in this address 127.0.0.1 8888, and you can see here that I'm connected to Nginx. So you know that pod and that application is running, and you can see over on the terminal, right, in my workstation on the left-hand side, that the connection is handled, right? So you can see here handling connection for 888. That actually happened as soon as I connected, all right? How do we get out of this? All you have to do is hit Control C, right? So now it stopped forwarding, and if I go back into the browser and I attempt to go back to that again, okay? So generally speaking, when I hit Control C and I come out of the port forward command, it should stop port forwarding. And you can see here, let's see if it's still doing it. Okay, it did stop. So it took a few minutes, and now you can see that it doesn't work. Now, if it gets stuck there, and sometimes this happens, you can do, you can grep, right, the port forward and get the process, right? So you're getting the process here, and then you can kill the process. All right, so again, one of those things that you can actually leverage. Unfortunately, there is no process because it was already killed, so it's not going to show anything. And the Control C worked. The Control C didn't work immediate, but after a few seconds, it actually stopped the port forward. So again, just to reiterate, we know that we have a Nginx deployment. Excuse me, I shouldn't say deployment. Nginx pod running. So get pods Nginx. You see it's running. Now I want to make sure it's working, so I do a kubectl port forward, the name of the pod, the port I'm forwarding to the container port that we specified, and now I should have access again to the Nginx deployment. You can see here I have access here. Okay, so that's just testing that the pod is functional and everything's working and the application is working. That's all we're doing here. All right, so let's Control C out of that. We'll hit clear, and now we're going to delete this pod. So let's K delete pod Nginx, and now it's deleted. Okay, so now we're just gonna add a namespace field in the Kubernetes Manifest file here, and where we add that is under metadata. Okay. And when you deploy an application, you're generally not going to deploy an application to your default namespace, right? The default namespace is pretty much what it is, right? It's default. It's not used for anything. And so when you don't specify a namespace, right, within your specification here, or if you're going to do an imperative command like we did before, if you don't specify a namespace, it's going to automatically put it in the default namespace. That's something that you want to avoid. Okay, so what we're going to do here is we're not going to use Nginx, or excuse me, we're not going to use vscode to edit. We're going to go back in and use our editor within Linux, within Ubuntu in my case, right? And we're going to do the same thing that we did before when we edited it last time. So I use VI, we're going to insert, and under metadata, now we're going to put namespace. Okay, and I'm going to call this test. So what I did here was I added the namespace field. Now if we go back in here, you can see here that this has been updated in VS Code now automatically because we did it in the file. So VS Code automatically looks at the file and updates it, and you can see here namespace test is there. So before we deploy it, let's do a list namespace. Okay, get namespaces. Okay, and you can see here that it's listing out all of the namespaces within our Kubernetes cluster. You can see obviously default is there, kube, the kube node lease, kube public, kube system. Remember we talked about kube system being critical to all of the Kubernetes management core components, right? That's typically where Kubernetes places its pods in the kube system namespace. But you can see there's no namespace called test. So what will happen if we deploy this without creating a namespace and then deploying it? Well, what's going to happen is we're going to apply nginx pod, right? I forgot the -f. Make sure you can see here namespace test was not found. Oh. So what happened is it saw that there's no namespace called test. So we have to create a namespace, right? So how we'll do this is we'll create namespace test. Oh, I put namespaces. And if I do get namespaces, now you see that I have a namespace called test. Now, you don't have to necessarily create a namespace and deploy a pod. We're going to talk about this a little bit later, how the namespace creation is included in your YAML specification. So if you know that the namespace has not been created as part of the of your rollout of your application, you're going to actually create the namespace as well. So let's go ahead, since we've created this namespace using the create namespace test command, and I do a get namespaces to get the list of namespaces. We're going to do now a clear, and we're going to do a kubectl apply -f nginx pod. And now when we look at this, if I do a get pod nginx, I'm not going to see it, because remember, if I don't specify the namespace, it's going to automatically go to the default even when I try to get information, right? So I have to specify that. And you guys need to get used to this, because you are going to see this on in your production environments, and as you go through the CKA preparatory practice exams, you're going to see namespace being used most of the time, because that's the habit they want you to get into. They don't want you to use the default namespace, right? It's not good practice. You want to separate your applications logically in namespaces within your Kubernetes cluster. Okay, so let's now delete this. Okay, delete pod nginx and test, and now it's deleted. And let's move on to the next section. So next we're going to talk about deployments. Okay, so let's create a file here again. Except we're going to do it under the main Kubernetes Manifests. Okay, and we're going to call this, actually let's create a folder. We'll call this deployments. And we'll use this folder. Alright, we'll create a file and we'll actually create deployments now. Okay, so let's X out of here, and now go into deployments. And we're going to create a file. Oh, automatically went down to Nginx again. Okay, and we'll call this test deploy 1. Okay, and so now I have a file here called test deploy 1. So what we're going to do now is we're going to go back to our Kubernetes IO site, and we're going to type in deployments. And you can see here, you want to click the first one, deployments. And the difference between a deployment and a pod specification is a deployment encompasses all of the things that you want to get to a desired state, right? So a pod is specific. So when the last time we created the Nginx pod, that's all we're doing. We're creating a pod, okay? We're giving it a name, maybe, assigning a namespace. We're putting the specification in there, okay? But we're not doing much else, right? Now there's other things we can do. We'll get into more of those things later, but in the pod specification, it's very focused on just the container piece of it, the pod piece of it, right? The application. But there are so many other pieces to deploy an application, okay? Other pieces are replica sets. So what are those? So basically a replica set is when you create pods, right? But you create replicas of those pods. So let's just say you have an application that needs to be highly available, okay? It needs to be always on, or you need many of these applications to scale, right? Based on your user or system interaction, or however interaction with that application is happening. Maybe you need additional copies of that application to actually scale. And what that is called a replica set. Okay? When we use deployments, we're describing a desired state. And basically what happens is Kubernetes uses what's called a deployment controller that changes the actual state to the desired state. Okay? And you can define deployments to create replica sets or remove existing deployments and adopt all the resources within a new deployment. So the idea of deployments is really about delivering everything you need, right, to create an application. All right? So let's look at a copy of this. And you can see here we have another Nginx solution here, but we're going to use a deployment. And you can see here there's other things within the YAML specification that we didn't use in the pod specification. All right, so let's copy this, okay, and let's paste it within our VS Code. Now again, you can use VS Code for now, but what I would recommend is that you use a text editor within Linux and copy out of these specifications on the Kubernetes IO site back into your text editor and save it that way. Because again, you're not going to have access to VS Code within the CK exam. If you're not sitting the CK exam and you want to learn quickly and you want a tool to actually help you with formatting and stuff, you're going to want to use VS Code. Okay? So let's talk about the deployment. Again, we see that. Let's go here. We're actually going to go we're going to go back here. Now we're going to go into the deployments directory, okay, and test deploy 1. So now we're going to do a cd mnt d home lab Kubernetes Manifests deployments. Okay, so if I do a clear here in ls, you can see test deploy 1 is there. We're going to now save this really quick here. We're going to clear this, and now we're going to make this bigger and walk through the deployment here. So again, we're going to be using Nginx as the application to deploy. Before we do that, I want to go back to the API resources. So kubectl API resources to get a list and go back to see why instead of why is this API version different than the pods. Well, remember what I said. When we go back to looking at the resources and the kinds within the Kubernetes cluster that we can consume, okay, we want to look at deployments. So let's go back to deployments here, and you can see deployments, the kind is deployment, and the API version is apps v1. So now you know, okay, by using this command, that's how you start. API version is apps/v1, the kind is deployment, all right? And the same applies here. We're going to name it, okay? We're going to label it. Again, you don't have to label it, but in my case, I want to label it. We'll call it Nginx. And then we're going to define our spec. Now, here's where it gets different, okay? Remember before, in the pod specification, we really focused on the container spec, because that's what really matters in the pod side of it, right? But if I want to, again, deploy multiple copies of this application, I need to assign replicas to that. And so I'm going to define my replicas. I need a selector to match the label app nginx again. So what happens is the spec defined here, it says, okay, replicas 3, so that's 3 copies of nginx, and we're going to look at selecting the label app nginx to assign those replicas to it. Okay, and we're going to use a template. And the template, right? I have no metadata, but I do have I have metadata, and the labels are app nginx, and then I'm going to define my spec for the container. Okay, now remember, we're using nginx here 1.14.2. We can change this to latest or any version. This is your pod specification for your actual application, and this is your specification that defines, right, copies of your application, and to use the template to actually create those copies. Okay, so this is what's called a deployment. All right, now let's go back here. Let's save this. I think I already did. Let's save it again. And now we're going to go back to our, and now we're going to apply this. So kubectl apply -f, okay, test deploy .1. Now we're going to do get deploy, and what do we name it? Remember, we named it something, nginx deployment. And you can see now it's changed. So if I do a get deploy wide, okay, I get a little bit more information. Okay, so I get the containers, the images, and the selector, which was app nginx. So now you see that I have a deployment that has 3 pods running. So if I do a get pods, now you see that I have 3 nginx pods running. Okay, and these are all the pods. What happens is it basically assigns a UUID for the pod, and that's how you get access to the pod. So if I copy this is very important, because when you start looking at troubleshooting and say 2 of the pods deployed but 1 didn't, you're going to want to obviously go in to describe that, right? Now I can actually describe the deployment as well. So let's look at that. And you can see here I use the short name. Remember I talked about short names? I don't have to do deployment. I can just do deploy. Okay? And now I can do a describe on that. So let's see what that looks like compared to the pod. Okay? So obviously it's a deployment. We didn't specify a namespace, so it automatically went to the default namespace. Remember, we labeled it app equals nginx, and we're using the deployment annotation. This automatically comes as part of the deployment specification. Remember, the selector we chose was app nginx. The replicas, 3 desired, 3 updated, 3 total, 3 available, 0 unavailable. So what does this mean? Now, you know I have 1 worker node, so all of these are running on 1 single worker node. Okay? If I had 3 worker nodes within the cluster, these pods would be spread out evenly across the 3 nodes. Okay? If I had more worker nodes, it would schedule the pods on the most available worker node as far as resources are concerned. Okay, but let's assume, for the sake of argument, I have 3 worker nodes, and we're actually gonna, in the next couple sections, we're gonna scale out our cluster, and we're gonna be able to see some of this. What would happen if I had the pods scheduled on 3 worker nodes, and one of those pods failed? All right. Well, it would automatically recreate. That's the beauty of Kubernetes, right? Because your desired state in your replicas was 3. That means that Kubernetes will always try to make sure that 3 copies of those pods are up at all times. What happens if I try to delete a pod? So let's clear that. Okay, what happens if I try to delete one of these? And let's see what happens. Okay, so delete pod. Oh, I didn't copy that right. Let's go back and get pods. Okay, delete pod again. Okay, so let's do this. I guess we'll have to do it this way. Spell. Okay, get deploy. Okay, get pods. Okay, so you saw what happened here. I deleted the pod specification with UUID 6VNFQ, okay, and automatically a new pod was deployed with the UUID ending in XGVPT, and it was up for 8 seconds, okay. Now that happens very, very quickly. So now I'm back to my desired state, right? So if a pod gets deleted automatically, or it crashes, or a worker node, so say, like I said, say I had 3 worker nodes and the pods were spread out evenly across those worker nodes, what would happen is a worker node went down, or say you went for an update, the replicas, okay, would automatically bring up another pod copy to make sure your desired state of 3 is met. And that's the beauty of deployment, right? That's one of the keys, especially with the replicas, one of the key things here. So let's stop for a minute here. Now, one thing we can do is we can actually edit our deployments, okay? So let's look at that, and what does that mean? So again, we deployed this Nginx deployment with 3 replicas, right? 3 pods running. So if I go okay, get pods, you can see here I have Nginx, 3 of them deployed. Okay, let's clear this. What happens if I want to scale down and I only want 2 copies running? Maybe I have overbuilt and I don't really need to have 3 replicas, and I'm using wasted resources. And so I want to pull back from the waste, right? And I want to only make 2 copies. So there's a couple ways of doing this, but I would recommend you do this. So we know that we have an Nginx deployment already created, okay? We can edit that using kubectl. So we're going to use the kubectl edit command, deployment, Nginx deployment. And you can see here that all of a sudden you're now able to go into the file, right, of the actual deployment, and now I can look and see exactly what's happening, okay, and how it was deployed. What we're interested in to scale down this application is the replica count. So I'm going to insert this, and I'm going to change that to 2. Then I'm going to escape, right quit, just like you're using VI editor, and I'm going to hit enter. So basically what we did is we went into the actual running deployment and we edited the replica count to 2. So let's what happens when that happens. So let's look at get pods or get deploy, whatever you want. Let's look at the pods. Since we're only running 1 deployment, I can now see I have 2 pods running, 2 replicas, right, in this deployment, because we scaled it down in real time. So this is another way that you would go in and scale down something or make changes to a running application. This is important for the CKA exam. I don't think it's as important in production, to be honest with you, because this is probably not how you would do it. And what I mean by that is, if you needed to make a change, a scale down change, right? That change in a production application would have to go through a change control process. There would be code. That code would be committed to Git. There would be collaboration on that code, okay, meaning that this YAML specification, right, of the deployment, and it would have to be approved. And so you wouldn't go in and actively edit, more than likely, I'm not saying you wouldn't, but more than likely you wouldn't edit an active application this way. I think what would happen is you would just redeploy with 2 replicas. Now, I'm not saying that you have to do that. You could go in and edit, but I think that's probably not the best case solution when it comes to active production environments. Now,
Some may disagree, some may agree. It doesn't really matter to me. What matters is that you're able to actually scale the application down or up. So if I went back in here and I hit edit and I went in here and I want 4 replicas or 5, I could do that as well. So if I change this to 5 and I right quit it and I get pods, now I have 5 replicas running within for that deployment for that application. Okay, I have 5 running containers, 5 running pods. Now, one thing you're probably thinking of is, how do I access these? Because before, when we did the pod specification, it was one container. We exposed it on a port 80. You showed me how to, Mike, you showed me how to do a port forward so I can actually access it. But how do I access each of these pods? Now, I'm not going to get into that right now. We're going to talk about services, right? Load balancing and those types of things here in a later section. Maybe next week, probably the week after. But in order to actually load balance across all of these, right, and we want to expose this service to our users, then we'll want to put a load balancer in it, and we'll want to use either load balancing as a service or ingress or a combination of the two, and we'll talk about what those things are later. I don't want to confuse you. Let's just focus now on basic YAML specifications as it pertains to pods and deployments. Now, there is another specification or resource called replica set, and what we like to do is we want to avoid just using replica sets. So let's go to Kubernetes IO, of course, going back to the source of truth, right? And we're now going to type in replica set. And we're going to click that link, and it's going to talk about how replica set works. Basically ensures, right, the specified number of pod replicas are running at any given time. And then we've proved that, right? We've scaled down the application. We've deleted a pod, and it showed that it recreated the pod automatically, right? Because I needed to have 3 at the time. We scaled up the application to 5, and it automatically assumes that you need to be in that state, right? That desired state. And so they recommend deployments, right? Instead of directly using because it provides declarative updates to pods along with a lot of other features. So, meaning you're not going to just do a replica set by itself in this example. Again, it is a resource. You can use it. You can create a YAML specification, okay, for it, and you can deploy it this way. But the deployment is the best way or the best method of deploying your applications, because in here I can define a replica set, okay, which I've done under the spec, okay. And again, when we get into more deeper rollouts, like adding services and exposing the application, doing some networking stuff, right, you're going to see that a deployment is much more than just, deploying pods, right, and saying, okay, this is many replicas. I can now go in here and do 3 dashes, right, and now do an API version of something else resource, and I can start a new specification. And for that deployment, it's going to do everything I ask it to do for my desired state. So if I have exposing it as a service, I could do that. Maybe it's a load balance service, which we'll talk about later. Maybe I need a persistent storage. I can actually create the persistent volumes and persistent volume claims here. Maybe I need to have a horizontal pod autoscaler assigned to the replica set, which you can actually see down here. So if you scroll down here, actually pretty cool use case here is this horizontal pod autoscaler, right? So I can actually go in here and say, okay, API version, maybe copy this code, and I can say paste this in, okay, and I can say, okay, I want to use a replica set, okay. Of course, I would change this. I would remove replicas here. We would use this replica set, this horizontal pod autoscaler. I would use the name, right, and I think the name is app label engine X. Right? The name is replica set. Minimum replica is 3, max, and I'm using a target CPU utilization percentage of 50. So what happens is, when it goes over 50%, okay, or 50% or greater, I'm going to now expand the replica, right? So I can go, okay, so say I have 3 replicas, and all of them are over 50% in target CPU utilization, it's going to scale another one. So I have 4 replicas. But it's never going to get over 10, and it's never going to be under 3 replicas, as an example. So in this case, we're doing horizontal pod autoscaling based on CPU utilization percentage, okay, which is a phenomenal way to actually deploy your application and make sure it's scaling, automatically scaling properly to the needs, right, of your business, to the needs of the application itself, and to your end users, okay? So I know I went a little bit further than what I probably should have done here, but that's just one example of why a deployment is so is the way to go here with pretty much everything. And as a matter of fact, I can do another dash here. All right, so let's just say I'm done with this. And now I can do 3 dashes, and I can start another kind service, right? And you can see here I'm using, this is why I like using Visual Studio Code, by the way, and GitHub Copilot, because it's automatically ingesting or recommending YAML specifications, right, based on what I'm asking for. So, and this is in the wrong place, by the way. This should be back here, right? So, basically, it's saying, okay, well, we know you have a deployment. We know you have a horizontal pod autoscaler, but you're not exposing it yet, so it knows. So it automatically thinks that a service is probably the next best thing because you want to expose this application to your customers, your end users, right? So again, I know I'm kind of going down a rat hole here a bit. There's probably, again, I know there's better folks out there that are explaining this better, but I would just say from this perspective, right, the deployment is the way you want to go. And so I think what we're going to do is we're going to end it here because there's a lot of information. We talked about some of the basics of YAML specification, right? Kubernetes Manifests is another term. We talked about API resources within Kubernetes and how you can access those resources by using the kubectl API-resources command to get the proper API version and resource kind, right, to start your manifest. We talked about how you can edit and create manifest files. Again, you don't have to use VS Code. You can actually go right within VI or text editor within Linux and create a specification from scratch. I like VS Code because it saves me time. It makes sure that my stuff is formatted correctly, which is great. But for your learning purposes, I would stay away from VS Code right now, and I would just use VI, and I would use the Kubernetes IO site, because that is what, again, if you decide to go down the CKA exam route, that is what is going to get you used to creating VML files, and you're going to start getting good at it in a sense where you're not going to have to worry about, some of these tools. These tools are just going to be there for reference, or in case you miss out on a formatting issue. There's no way you can memorize all of the YAML indentations and how it's laid out. Some people probably have. They probably do it in their sleep. But for me, I have to have a tool to kind of help me there, because I don't do this all the time. Now, if you're a Kubernetes administrator, you plan to be like a Kubernetes operator or a platform engineer, you'll be doing this a lot more. Unfortunately, I don't do it as much, and so I'm not as comfortable with it as someone who would do it every day. But that's why you have sites like Kubernetes.io. That's why you have tools like Visual Studio Code with GitHub Copilot to help you along your journey. So I hope you have a great rest of the weekend. I hope it's a long, rust-filled weekend for folks in the U.S. Happy Memorial Day. I'd ask that you please, in remembrance of our troops, right? If you see someone in uniform, or if you know someone who's a veteran who is in uniform, please thank them for their service. As a vet myself, I make sure that I always look, for folks and thank our folks in uniform, because they are willing to give the ultimate sacrifice for our country. So again, I hope you have a great rest of the weekend, a rest-filled weekend with family, fires, barbecues, etc. And we'll see you next week. Thanks.